That was terrible. Okay, good evening, everybody. This is like an amazingly late session. Wow. I'm super impressed that you're all here. I'm super impressed that I'm here at 6:30 here on what day is it? Thursday? Thursday. So hopefully this can be the final send-off for your evening, and you can go do whatever you're going to do, drink or eat or whatever after this. Who's already had a drink already tonight? Sweet. Me too. Okay, so it's going to be great. This session is going to be awesome. So what are we going to talk about tonight? The demystification of the app development platforms on Azure. So we're going to talk through a lot of the different capabilities that we have, the different platform as a service offerings we have on Azure, and try and explain them in a way that makes a little bit more sense than perhaps we've explained them in the past. And so try and give you a picture of a lot of the platforms, and then go into some demos and actually walk through some of the newer releases. We'll do a demo of Service Fabric, we'll do a demo of Functions and App Service as well, and kind of walk through a few of these and sort of show you the difference between them. Just as a show of hands, how many people went to my other session? Okay, great. So there is a couple of slides that will look similar to you folks who did, because I clearly wasn't going to make two sessions. So I copied a lot of slides. How many people have gone to a session on Service Fabric or Functions? Okay, good. So there will be a little bit of overlap. Some of the demos are different, but we'll walk through it. So let me just get started. Okay, the cloud is changing expectations. This is something we're seeing across all industries, across all customers, no matter big, small. The overall dynamic of the cloud is dramatically changing all customers and the way that they approach development and application deployments. And this change is really driving a lot of requirements on the platforms behind them. And so a good example, as we look at a lot of the different industries in the market today, we start seeing that every single company is becoming a software company or is getting pushed out by a company that has become a software company. So great example, of course, is the Netflix Blockbuster situation, where the onset of Netflix and the ability for Netflix to effectively create a new business model with the software that they built has pushed out many of the brick and mortar based solutions that sit below them. Another good example of this, of course, is Uber and taxis. And you notice all the old and dying pictures are black and white. That's for effect. So the pictures of taxis, of course, the concept of Ubers coming in and taxis no longer being relevant, or at least not getting as much of that usage once that Uber capability built with that software backend really took off. And of course, Skype and the telephone, and the ability to effectively replace I don't know the last time I've seen someone actually on a payphone, and it's actually very bizarre to try and think back the last time you used a payphone. It's very uncommon at this point, and not just because of Skype, cell phones, of course, as well, but the whole concept of telephones have dramatically changed thanks to all of the investments and improvements that software has brought on. And so as all of these companies change, there's really this sense of if you're not moving to that next generation, if you're not moving to that next phase of software development, you're probably falling behind. And some great examples, though, of companies that have actually successfully moved or in the process of moving. So one, of course, we talked about this morning, BMW and their futuristic car, which was super cool video. I'd love to actually get that car in reality. But the ability for BMW to transform themselves as a company to start looking towards being actually a delivery of software versus just a delivery of cars, and how that software can interact with all of their life aspects is really changing the way that they approach their entire business model. NBC as well. NBC, of course, as many of you know, a broadcast company, the national broadcast company. I think that's what the N stands for. And the amount of television programming that they do, the amount of money that they make on advertisements in television, but the change for them of they have to make this content available online or they will start losing to other online companies that are making it available. And this was a great example running on top of media services. They actually set the record for the amount of viewers in the last Olympics to be watching a single event through media streaming. And so them taking their platform forward and really thinking through that next phase. And Alaska Airlines is another great example, actually the airline I flew to get here, thinking through a lot of the way that they approach IoT and the way that they approach customer experience on the devices that they make available on their planes and how customers are using them, and taking that and building an analytics pipeline around it is, again, really changing the way that they think and really approaching it from a software perspective versus just from a we fly planes perspective. And so that aspect of change can both be very good, but can also be very troubling for a lot of existing companies. And we're seeing this across the board, no matter what the industry is. The great part about what we offer here at Microsoft is the developer focus that we offer. And this is something that it's not new to us. This is actually a logo from, I guess, the 70s or early 80s for Microsoft. We've been very developer focused for a long time. This is a real picture of that original team. And so bottom left there is Bill. And so this has been around for a long time. I feel like this is relevant for this type of picture. So we've been doing this for a long time. Developers has been the key focus for us for a long time, and the cloud is just another step in that process. So you may ask, great, but what are app developers really looking for today? When I show you those companies, the companies that knocked out existing companies, when I show you the companies that have continued to survive by reinventing themselves, what really are developers looking for? What are you looking for? And I do sum it up pretty much in one word. I think agility, I think time to market, I think the speed at which deployments can happen and the speed at which applications can be delivered is probably the most crucial aspect of how applications and companies can reinvent themselves and move forward into the future. And so what does this actually mean? Well, what is agility? It's said a lot. The press talks about it a lot. What does it actually mean? Well, it doesn't mean being able to run this type of football gambit thing. No, it's more around how quickly you can get your application and your code into your customers' hands. And so it's both a question of time to market, time to value, but then also it's a question of iterative speed. And as I walk through some of the capabilities that we've come out with and some of the capabilities that we're really focusing on, this is the theme that really carries through all of it. How do you get that value to market really, really fast, right? Being able to differentiate between hours is now necessary to be able to win against your competitors. And then how do you iterate? How do you learn? The amount of times that we make mistakes, even in Azure, if you can believe that we make mistakes in Azure. No, okay. Thank you. We do make mistakes in Azure, I know. The amount of time that we could ship something, realize that was actually wrong. We made the wrong choice there. Learn and reship. It's crucial to being able to continue to improve the service and the value that's offered. If you remember those original customers I listed, the Ubers of the world, the Netflix of the world, they were all wrong in their first release. They were all wrong in the way that they approached it the first time, but they iterated quickly and they were able to learn and fix themselves. And that's super critical, and again, a key factor in how we approach the entire service and how we approach all the different application solutions that we offer in Azure. And so that agility is absolutely key. It does come with two other elements, and so I will just touch upon these. Hyperscale and availability are two other key elements that come together when you're looking to build an application that can really scale to the cloud and take advantage of the cloud power. And just to give kind of a brief overview of these three, I'll just touch upon each one. One, of course, is being able to scale very, very quickly at an application level and being able to scale out very quickly and scale back in really quickly. And all of the services that we talk about today have that capability. One is also being able to scale at a container level. This is a very new concept, but it is one that we're seeing pick up. The agility that's offered, the speed, the deployment, and then, of course, the scale capabilities that come with containers really make it very advantageous to this entire movement around being able to get fastest time to value. When your application can spin up in seconds versus minutes or hours, suddenly you can really test things quickly, learn, and iterate very, very fast. And again, you'll see a lot of these concepts today. And then, of course, this global scale. And this is really where the cloud offers a lot of unique benefit, being able to deploy across the world in many, many different regions. From an availability perspective, one is, of course, resilient to infrastructure failure. All of the services today have that capability, the ability to respond to a machine dies, and the app can continue to run. In fact, the platform fixes it for you. And you'll hear us echo that throughout the day. Very important to be able to get that agility. The other one is, of course, resilient to application failure. And of course, the best example we have of that is Windows Vista. It's too soon? Oh, okay, sorry. We'll cut that in the recording. Okay, the ability to respond to application failure. You saw it today in the keynote. The keynote this morning showed a great example of the deployment of that buggy thing that Scott Hanselman did. And I've been trying to tell him, stop, that's a wrong code. You shouldn't put that in there. But he did it anyway. But that ability to respond to that failure and come back, very, very critical to being able to deploy applications in the modern era. And then, as I mentioned, agility. Simple tooling integration, very fast time to market, and of course, services to help. And whether it be integration with things like Twilio, Auth0, GitHub, etc., all of these things become very critical to be able to get your simple applications moving forward and very, very easy to deploy and iterate on. Okay, so across these three, very, very exciting, and the services I'm going to walk through today all span different capabilities as part of these three. So the next question is great. So what do you have? What are the choices? And candidly, Azure's got a ton. We have a ton of application services, and this is why we have so many services, we need a session called Demystifying, because there's just so many of these services, it's amazingly confusing how to go piece these things together. And so there's a lot of choice. And we've struggled, actually, to be able to explain this choice. We've struggled in a lot of ways to be able to tell you when you should use things. We've shown pictures like this, which are amazingly simple for you to go take a look at and say, oh, that's what I want. It's really hard, right? I mean, this is basically a picture of every service we have in Azure, and it's nearly impossible to figure out what you're supposed to do with this, other than perhaps put it as a screensaver. And so it's really, really hard. It's a great picture, a great map of all the services we have, next to useless for you to be able to pick what you want to do. So then we tried something like this, where we draw these continuums and arrows and picked things and called things SAS and drew arrows over time to value and differentiation and tried to split up between developers and so on. And these are also very, very challenging. They're very challenging to understand what, again, are you supposed to do with this? When do you pick one versus the other? And how do you make that selection make sense, right? And so I'm going to try a different tack today. I'm going to try a different approach to try and demystify. And my approach is going to be more pivoted on what is the app that you're building? What problem are you trying to solve? And then let me tell you what we offer to be able to solve that. And so let me start off very, very simple. So the platform splits up kind of into two categories. The lower level is infrastructure as a service. And while this is technical and sort of the actual product that we have, it does help explain a category of development that you may do, which is you need to be on the VM, right? For one reason or another, you need to be able to go make changes to the VM, make edits, make updates. There are many applications that is definitely the case, and it makes a lot of sense. And so we have two types of categories for that. One is the VM and scale set category, and the other is just raw containers. And this is really, really powerful, lots of control. You can do whatever you want on these things. So with the VMs, you can spin up 1, 2, 3, install things, they live on, and you can basically nurture them. If you install, let's say, a SQL server or maybe a SharePoint farm, right? And you can build your app that way. With scale sets, I'll talk about in a minute, you can scale out very, very massively. And then, of course, containers are effectively the same concept as VMs, just smaller and faster. And so raw containers, again, very much fit into this infrastructure category because they just deploy the full OS bundle in a single click. They're just a lot faster. And so they do kind of fit into that same category. So just to explain briefly the VM scale set and VM story. The VM story is every single VM is individualized. So if you're using VMs and you're building apps with VMs, every VM is its own guy. So Cori VM, Cori VNet, Cori Storage, and they all live separately, and I have to go nurture them and love them, and so on. They're my pets, as it were. And then maybe I have a second one that's Mark, and it's the same sort of story, and deploys that way. Now, scale sets, which Scott mentioned this morning, is GA today. This changes the concept a little bit. It pieces all these things together as a unit, and suddenly I can scale in an automated way, and I can deploy in a very automated way. And so here you see I've got, let's say, 6 scale sets here, and I can deploy them, and they just deploy. They auto-scale automatically as needed, and they deploy as a single unit. So 1, 2, 3, I build my app, let's say I build Chef on it, or I want to deploy PowerShell on it, or I want to deploy Bash script on it, it will do that in an automated way and scale them as necessary. And so this is the core component for the infrastructure layer. We build on top of this the container service. And this is, again, building a deployment of just raw containers. And this just places this on infrastructure. And so if you're building an app with a VM, or you want to go scale out and you want to build scale sets, or you want to put it into a container and deploy very quickly, this enables very fast raw container deployments on either the Mesos plus Marathon platform or the Swarm platform. And what these guys do, their primary role is to orchestrate. They find a spot on a VM and they deploy. Okay? And so this really is, while you can build lots of application solutions on this, the core technology that we're offering here is sort of a simple raw container deployment. And so the container service, it kind of grays the line between infrastructure and platform. It finds a home for things, but if you're building an app that's just using containers and you just need to put it somewhere, the container service is great, but it is closer to that infrastructure layer than it is in the platform layer. Okay, and so that's the full IaaS layer. Now, the rest of the talk is really focused on this layer above, this layer that I call platform. Excuse me, that I call platform. And it really splits up into 4 different types. One is if you're looking to build microservices, and I'll explain what that is and the type of scenario that would entail. One is existing frameworks. So you're deploying, let's say, an existing .NET, an existing Java application. Maybe you're deploying web and mobile applications. Or maybe you're looking for serverless, event-driven based applications. So this breakdown, again, it's a very simple view. And the goal is to pivot the view based on what you're trying to do. And this isn't based on your full app. Right? And I'll talk at the end about how some of these pieces can come together. You can put pieces from this and that and this and that and make a full application. But for specific portions or components of your app, what are you trying to do? Is it a web portion? Is it a mobile portion? Then you've got the service for you. And so this is how I'm going to try and describe it, and we'll walk through these demos with that context in mind. So let me explain to you what I mean. So the 4 different components: serverless, web, mobile, microservices, and existing frameworks. So serverless, this was Azure Functions as the example mentioned this morning. This is really geared towards event-driven compute. So it's where your application components are trying to respond to some event, whether it be an IoT-based event, maybe it's a gaming event, maybe it's a phone or mobile event, maybe it's actually an event in another microservice platform. The whole idea is it's event-driven, it is serverless, which means you are not managing any of the infrastructure here. All you're managing is this snippet of code, and you're saying, based on an event, I want to run that. And this is really a category that's starting to really blossom as a great supporting category across the rest of the advanced services that we have. So pretty much every other service that we have, you probably can find a way to make it better with this serverless capability. The next is web and mobile. It's kind of obvious. You're building a web and mobile app. You want to build a fully managed solution, no infrastructure management, maybe an e-commerce site, maybe an LOB app, maybe supporting websites. All of these are really, really great to go build. And of course, they're one of the more common apps. Actually, the most common services and applications built on Azure today are focused on web and mobile apps. The third is microservices. This is its own category of application. And I'll go into a lot of detail later. But microservices, if you are looking to build a massively scalable, 24/7 available, yet highly agile, multi-component application, microservices is going to be the place for you. Now, microservices is not the answer for everything you're building. There are a lot of things that don't fit into that category. And you want to be a little bit careful, or at least very choosy, about when you build microservices, because it will be costly. Right? It's going to take work. You're going to have to think through your app in a different way. But microservices, when done right, things like that multiplayer massive universe game that we showed this morning. We've seen folks use it for queuing systems, very massive, complex queuing systems on top of storage, or actually using the storage as part of microservices. Or large sites, very complex solutions. This is where microservices can be very powerful. And so it is really geared towards those types of applications and can be great when used correctly. And then existing frameworks. This is really when you're designing your app geared towards a specific language or runtime that you'd prefer to use. So if you're building your app, you're like, I'm a Java guy, and I just love Java, and I'm going to use Java. Or I'm a .NET guy, and I love .NET, I'm going to use .NET, but I want to get on the VM a little bit, and I want to be able to configure things a little bit my way. This is where this existing framework model makes a lot of sense. And so I'll give you some examples of those as we walk through. And so this could be maybe an existing enterprise app, an LOB app. Maybe you're doing a new scale-out solution, but with some existing components that are tied into the underlying system. And so these are sort of the four big, when I talk with customers and we walk through what's your app going to look like, these end up being the four big platform requirements that we see. And you'll see at the end, I'll put these pieces together to show you applications that span all these different components with a single all-up solution or service. And so for Azure, the services that we offer, once you break it down into this category, it's actually quite easy to be able to subdivide our services. Serverless, of course, is Azure Functions, which we talked about this morning. That is in preview today. Web and mobile. App service is absolutely the solution, and this enables very fast web, mobile, and of course API apps tied in with that entire solution space. With microservices, Service Fabric is the answer, and we'll show a little bit of that today. And then, of course, existing frameworks. The solution we have today is cloud services. This is a perfect example of a .NET-based existing solution to be able to deploy some VM native code, but being able to deploy in a PaaS-like environment. And so across these four, very, very powerful stuff. Now, we have partner solutions that also complement this stuff, and I'll talk about that in the very, very end, that you can say, great, existing frameworks, well, what about Java? You said we have a .NET solution, do we have a Java? So we do, right? We have a lot of partnerships on the Java side, whether it be, let's say, Pivotal Cloud Foundry, whether it be OpenShift, and so we do have that wide range as well. But I'm focusing today mostly on the Microsoft services and the capabilities therein, and these four do perfectly align with those four scenarios that we see customers trying to deploy. Okay, let me actually dig in here. So cloud services. I'm just going to touch upon cloud services. It's the oldest service we've got, and so it's been around for a while. But the overall story here is cloud services offers platform as a service, but with VM control, right? And it gives you the ability to go in, modify the virtual machine. It's a simple .NET runtime. It's a very simple experience, and it gives you really just the tipping point of PaaS. You're still on the VM. You still have to install your apps. But it does some things like health and discovery. It can do automatic updates. And probably the most valuable aspect of cloud services is it does do OS patching. That's really when you sit down and say, well, why do you use cloud services? It's almost always because, well, I have to install something on the VM, so I can't use your other services. I've got existing applications or an existing solution, but I love your OS patching, so I'm going to use cloud services. That is almost always the answer we hear for cloud services, and it's super good at that. That is exactly what it's good for, and it continues to be good for that. And so a lot of the advanced services we talk about later today, they end up not giving that full VM control, and that's sort of where they start changing as you move up. But cloud services still gives that existing framework control, and that's a big value add there. Okay, so let me talk about Service Fabric. So Service Fabric, this is a microservice-based platform. And so let me just spend a minute on what this thing is. What are microservices? So when you split up and look at microservices, they're effectively taking these concepts of massive, monolithic, three-tier solutions, or multi-tier solutions, excuse me, and splitting them up into subcomponents. And it's really important to understand why that's interesting. So historically, you were making an update, let's say, to your business logic. Let's say you were making an update to your order management portion of your application. You historically would have to go test the entire business logic component. You'd have to make sure everything about it was working perfectly, that there was no hidden dependencies on the changes you made, right? You need that whole team to be in the office to go test it before you deploy. You probably needed the other two teams too to make sure that all the interaction didn't break, because who knows what sort of dependencies there were across that whole thing. It made the entire system amazingly non-agile, right? And especially as you looked at scale and highly available solutions, very, very challenging to make that work. So what the value of this microservice model is, it makes these components individually built and deployed. So now I can go update the order management tool and know that nothing else is going to change. Everything else is going to remain the same. I don't need the usage guys to come in or the reporting guys to come in. I just need the order management guys to come in to go make that change. I can iterate really fast. Again, remembering back to that agility point, iterate fast and get your fast time to market. This allows you to do that, and that's really one of the benefits. And of course, this enables those small, independently executing components to continue to have that health and that independent health model continue to remain in place. So if something fails, it can respond to just that subcomponent. To make that work, of course, you need all of these microservices to have published API calls between them. So every one of the microservices, when they talk to other microservices, they need to have a published API that can be fully validated and tested. It's a really hard part about building a good microservice platform. So this should not be overlooked. It is, again, one of the challenges. It's also, when you do this right, you get those benefits in amazing dividends, because suddenly you can make updates to that order management and know nothing else will break. But until you have those API constructs, it's very, very hard. And of course, this also makes everything very loosely coupled and fine-grained. So you can make these updates very simple and very agile. And so this platform, the platform that runs these needs to have a few aspects, a few characteristics that we view. One is lifecycle management, being able to do updates and rollbacks, being able to support a highly scalable infrastructure, being able to run in a hybrid way. We actually think running on multiple clouds is a requirement for a good microservice platform. And of course, having that high availability and being very cost efficient, being able to use your resources very, very well. So we do believe pretty strongly Service Fabric fits this demand and many more requirements. It allows you to manage these microservices at scale. It integrates with your CI/CD pipeline and your Visual Studio tooling. It gives that 24/7 availability. In fact, we run so many of our services in Azure on top of Service Fabric. DocDB as an example, Cortana as an example. All of these are running on top of Service Fabric. One key thing, stateful services. Scott Hanselman talked about it this morning in the keynote. This is a really valuable aspect of Service Fabric. You can put your state right next to your compute. It gives you very, very high performance. It also automates the replication requirements of that state. So if you want 3 copies, 4 copies, 5 copies, the platform will take care of it for you. An instance dies, it will automatically fix that replication state and re-replicate back out. So this is why things like SQLDB actually use Service Fabric for its underlying system. For containers and Docker, so today the Linux version of Service Fabric does support Docker and does support containers. The Windows version will support this as Windows Server 2016 makes its way out the door with container service brought with it. So we do expect to have Docker containers supported across this entire platform. The one key thing that I like to call about for containers and the aspects and relationship between containers and microservices, I do believe that all microservices will end up being containers, but all containers are not microservices, right? You can put anything you want into a container. You can put a full SharePoint farm, conceivably, into a container and deploy it on a box, right? That's clearly not a microservice. So I do think that we will see that almost all microservices will move to this model, but this model, the Docker and container model, is not equivalent to a microservice. And then multi-cloud. This is something we also announced today. You can deploy this on-prem. You can deploy this in Amazon. You can deploy this in GCP if you want to. And that is a really cool aspect of Azure Service Fabric. So I've talked a ton, probably way too much. Let me actually do a quick demo of the Service Fabric story. OK. So what I've got here, I've got an application running here in Visual Studio. And what I'm walking through right here, this is actually fairly similar to one of our walkthroughs that we have, so you can go walk through this yourself and play around with it. But this is the visual objects. Who's here has played with visual objects on Service Fabric before? Oh, cool. OK, 1. Sorry. This is going to be boring for you. All right, so visual objects. So what I'm going to do first, actually, so I've got this application. I've downloaded it. You can see I've basically got a few services over here. And this is building upon the actor model. And what the actor model is basically a simplified programming model in Service Fabric to make the concepts of microservices easier to comprehend. It's effectively the object-oriented approach to microservices. So each actor is its own microservice and then basically builds out contracts with everyone it's going to talk to. So I've got an object, an actor object, that is a stateful object, and they're called visual objects, and they're basically little guys that dance around the screen, and they bounce around, and they leave a little tail behind them, and that tail is the state of that object. And so what I'm going to do is I'm actually just going to start off pretty simple and do a publish here. I'm actually going to show you the local publish, okay? And so it just very quickly deploys and launches here. And so this actually launches on a local deployment of Service Fabric. Now, what's cool about Service Fabric, this is not an emulator or a simulator. This is the actual code running on my box. Similar to running it on-prem, running it in another cloud, it's the exact code. The only thing that slows me down here is my machine's power, right? And so that, obviously, you'd want to put it on multiple machines as you started growing these things out. But this is just running my code on the box. And so here you can see I've got local host set up here. And you can see here I've got, from an application perspective, let's actually go back up to the cluster. I've got 2 applications and 5 nodes. And these 5 nodes are actually simulated nodes, but the actual code here, the Service Fabric code itself is not. And so I can click on this, and you can see I've got basically the objects for this visual object deployed. And so here you can see the actors are deployed. And so there's a few of these actors deployed down here, and I can see sort of the state that's been used here. And so let me actually see if this is up and running. Okay, let me go localhost. Okay. And so there it looks like it has deployed. And so this is what this guy looks like. Okay. And so these guys are the visual objects. Each one of these is an actor, and it's dancing around, and it's basically got its location, and its movement patterns are defined by the app, and its little tail is the state that's saved as part of that actor object. Okay, so I want to deploy this in the cloud, though. But look, I don't want to go spend the time or the money to go spin up multiple nodes. So one thing that you should definitely take a look at, party clusters. These are things that we've come up with to make it really easy for you to deploy in the public cloud. So you can go to one of these party clusters and basically say, look, I want to go play with this. It gives you access to a 5-node. These are 5 virtual machines, very large, deployed in the cloud to deploy your application. Now, this is shared. So there could be many people on that deploying. That's why they're called parties. And so they are shared environments, but you don't have to pay for them. You put in your email address. You put in basically that prove that you're not a machine here. And so I can go here and put in my email address and prove that I'm not a robot. Okay. And that's my email address. You guys are all going to email me now. Good, that's fine. I don't read it. Oh, I'm already in one. Okay, I already set up my cluster. So you can join this. It'll send you an email. That email looks something like this. And it gives you basically the address of this cluster. And now you can deploy whatever Service Fabric solution you want. So let me actually go in and deploy. I've got one set up here. So publish. And I will go to cloud.xml. So here you can see I've got party 41. And that's the port for Service Fabric. So I will publish here. And so this should just publish and get me going here in the public cloud, running on top of Azure. And so let me pull up the service. And the exact same Service Fabric Explorer. This is a key point. Same Service Fabric Explorer, the one I had local, the one I have here. It's deployed as part of the app, which means you deployed in Amazon. You'll see the same Service Fabric Explorer. That's part of the benefit of doing this. And so here you can see, oh, look, it's unknown. So it looks like it's deploying, or I did something wrong. Oh, good. OK. I didn't do something wrong. Oh, maybe I did. Oh, yeah, just deleted it, and now it's deploying the new one. OK, and so this should end up deploying effectively that same model. OK, great. Should be there. Let's see if it's up and running. Looks like it's upgrading here. Let me try and load it again. And so you can see from that Visual Studio experience, I'm just picking the endpoint. So even from Visual Studio, the same tooling will work no matter what environment I'm deploying to. OK. Let's see if it came up. OK. So there it is. Let's see, did it actually, are my guys spinning? It's still updating. OK, thank you. So the key thing here is the ability to go deploy in multiple locations, deploy in that local environment, deploying in the public cloud. Now I can do updates as well, and you saw one this morning. As that update rolls out, you can see it, of course, in that local environment and know exactly what's going to happen. You can update just the actor and be able to deploy. And so just to quickly show you what that looks like, here I've got some code, and right now these objects are not moving. They are actually keeping steady and just they're not spinning. They're actually moving on a straight line. In this case, if I make this change, and I go and edit the manifest version, I just want to make sure that only that code that I've updated gets edited. So I'll put 2 here, okay? And that allows me to control which microservice gets updated, and then I'll do upgrade application. This will actually go in and it will upgrade. Okay, so there they are spinning. And so this will go in and it'll actually upgrade them and start spinning them update domain by update domain. Okay, and so again, the benefit of this, I'm only updating that actor, right? I'm only updating it one by one or by update domain, so it's 20% walking through. And it's updating nothing else. So the website itself remains up even while the update's happening. If something fails, there's no problem. It can roll back. All of these aspects, again, the huge benefit of the microservice platform and the huge benefit that Service Fabric offers to be able to enable that at massive scale. So you can imagine this type of app deploying at very, very massive scale and being able to have that control and capability. And so here you can see we've got some updates that are actually happening right now. And so there's the upgrade right there. Let me zoom in here. Okay, and so go to the details, and you can see sort of the upgrading story right there. And so if I go over to the site, I don't know if anyone's actually been updated yet, but as these guys get updated, they will start rotating instead of just going straight. I don't know why it's so jumpy. I think the Wi-Fi here is troubling me. So that update will progress. So I'm actually going to come back here and go back here to the deck and walk through sort of the rest. So that is sort of that model around microservices. Again, it does take work to get there, but if you're deploying that type of app, very, very powerful. So I do like to take just 1 minute and explain this part of the platform, which is this microservices stacking. So the scale set's at the bottom, right? This is the way that the platform sits. Both the Azure Container Service and Service Fabric sit on top of scale sets. We do have 2 different approaches to building these types of applications. As I mentioned, our container service is very composable. You can put anything you want on that. It's really in your hands to deploy exactly the solution, the application you're looking for. Service Fabric is much more prescriptive. This is the big difference between these two. The container service, whatever you want. Applications, they're pre-built. You can use the Mesos-based, the Marathon-based solutions. You can put all types of pre-built applications on it and build your own microservice platform as part of it. Service Fabric, it's all sort of built in, right? And so it's got that prescriptive nature, which also means it's not replaceable. It's not composable. You end up using the platform as it's been built, which has both really good positives, but also can have some negatives. And so again, it comes down to what is the app you're looking to build. Both of these are very, very powerful and again, unique for us to have both of these in the same place. Okay, so let me move up the stack. App Service. So App Service, you've heard plenty about App Service. And it's a fantastic service, again, focusing on a lot of that customer-facing web mobile API solution. And so building a great web and mobile app with App Service, the combination of these solutions, web apps, mobile apps, logic apps, and API apps comes together in this single billing model as part of the Azure App Service. And so the real benefit here, and Nir's going to come up and show it here in a slide, is a bunch of these capabilities automatically handled for you. So you're building a web solution, everything's handled for you in a lot of automated ways. So automatic patching. You don't have to worry about any of that OS patching. It's all taken care of for you. Autoscale is taken care of for you. You actually don't even need to think about that you're running on VMs. It actually doesn't matter, right? As you build these mobile web apps, you just don't care. You're building the app based on the solution, the code that you're writing, and all of that's taken care of for you. It can integrate with SaaS-based solutions and can integrate and deploy into on-prem environments as well. And so very, very exciting capabilities. And of course, that agility point, coming back to that from before, this continuous integration with tools like VSTS, GitHub, Bitbucket, and more, you can now get this deployment running very, very quickly. You can respond to changes and get them deployed live almost instantaneously. And to show you this, I've got my good friend Nir, and I'm not going to say his last name, and he's going to come up and give a quick demo of this.
Thank you.
Thank you,
switch the machine?
Oh, yeah, I'll switch the machine.
Thank you. So we've had, well, I'll try to log in. We've had App Service for about 4 years before we launched in preview. So how many people did use App Service in the room? All right, so a few of you. So we'll go to the first demo real quick so we can have time for functions, which is brand new and has some new scenarios. But like Corey was saying, the focus here is on agility, and the focus here is on practical things web developers need to do. And when we started App Service, the whole goal was to say, I have a web app, it's running on IIS on the local web server, I just want to take it to the cloud. And as the service grew in the last 4 years, we've seen more scenarios like APIs and mobile and so on. So this first one is, I have an existing website, it's running some Node.js code, and I'm already integrated with GitHub. So to save time, I did not create the website and create the integration, but you'll believe me that it's there. There's a webhook that connects GitHub to my GitHub repository to this website or web application. Here's some history about the last deployment, and we can go ahead and browse to this site and hey, hello app service. And then I can go to GitHub and make a quick change. So it's late. I'm sure we want to get to the next stage of cocktails here. And at this point, what will start happening is we're going to start seeing the new deployment. Again, very simple demo, but the main point here is great. I can have my team develop against GitHub. I can use different branches, and the code that gets pushed into production does that automatically. And we can see this new deployment, I believe, is already done. So I can go back and browse to my site and hopefully see this change. Again, very simple. That's kind of the 101 demo that we always do, but the capability is very powerful, works with GitHub, local Git, VSTS, and so on. The second demo is a very simple case that we all had to do. All of us have been developing locally using Visual Studio. And in some cases, we have our local development environment. We have our local settings to connect to our database, for example. So in this case, I have my super easy, cheesy web application. It takes custom setting from web.config, my slot. The value is locally, and I'm going to debug it on this machine. And when I push it to the cloud, obviously, I don't want to push this web.config with my secret and see it all over the place in production and break my application. So there's obviously a risk with this agility. I can push something to production and break it very easy. So we're running on local. With App Service, we have this feature for app setting that basically allows us to say, let me go configure something on the back end. This travels with the application settings. And those settings win in production. So as we can see, we have this my slot, and the value is pod. It's marked as a slot setting because, again, for brevity, we didn't go into the next demo, where I can create these pre-deployment slots and a pre-production environment. So in this case, as I browse to this website, we can see that we're in pod, and the app version is 2. And to finish, again, showing you how easy it is to go ahead and push to Azure. Let's say we want to go up to version 3 now. And we'll go ahead and do a publish. I should probably stop debugging. And we have this very deep integration, just like we've seen with Service Fabric, between App Service and Azure. Sorry, between Visual Studio and Azure. And at this point, we're pushing using web deploy, and we're pushing the new bits. It knows that's only one file, and it should be happening pretty quickly. And we're loading this thing, and it's 3, and we can see that we're in pod. So very quick taste of App Service. All of these capabilities, and like you've seen in the management portal, there's a huge list of capabilities and features and settings that you can drive, are based on this being around for 4 years and listening to our customers and understanding what they need practically to run and manage their applications. Thanks.
Great. Thanks, Nir.
Yeah. Mm-hmm.
You can stay nearby. OK. And so the very top section of those 4 sections that I originally started with is Azure Functions. And this is something that, again, was announced today in preview. A very exciting capability. It is event-driven technology. And so the idea here is you've got a little bit of code. OK, you've got a say a function even of code, and you've got some event, some data that's coming in, some action that's happened. And again, I like to think of this as sort of like fairy dust that sits on top of the platform. It integrates with everything. So any event that happens, you want to run some code on top of that, bring them together, and you've got our Azure Functions capability. And so with Azure Functions, very, very powerful stuff. You can take this and apply it to any event. So drop an image in storage and take an action. Go through an Event Hub endpoint and take an action. Write the code that you want in the way that you want it, right? And so capabilities to deploy both C#, JavaScript, and of course deploy executables across a wide variety of different languages. It is deeply integrated. The things that you just saw from Nir, it is deeply integrated in the DevOps story, that end-to-end Visual Studio integration, which you'll see here in a minute. And again, of course, pay for what you use down to these functional components as part of that overall app service plan. So really, really powerful stuff. And of course, as we announced this morning, open source capabilities to run this anywhere you want. And so some awesome stuff. And again, I'm going to ask Nir to come up. And so we're doing a little dance to do an Azure Functions demo and focus on some of the cool things there.
Cool, thanks again. Let's see.
You're on.
Oh, I have a meeting. I'm sorry, I have to.
Oh, you have to go?
Yeah.
All right, well.
All right, you do the demo. OK, cool. Let's see.
Do you have an Azure function based on that meeting request, or?
That's coming. Cool, so Azure Functions, one of the important points to mention, it's based on our WebJobs SDK. WebJobs is a feature that we had we announced actually in January 2014, so it's been around for a while. And the goal there was to essentially use the same value that we've seen before of the continuous integration, easy to deploy, deep integration with Visual Studio to allow us to do some backward processing, kind of the canonical scenario of someone uploading an image or creating a transaction, putting the transaction on a queue on your front end, and then processing it on a back end. I guess Ibiza is really wants me to do something. Hi. Cool. As we moved forward, we've gotten all this feedback from our customers saying, hey, we'd really like this thing to be more of a first class. And we did this push in the last kind of 3 months to get it out as a first class service that we announced today. So one hand, it's brand new, but we have some high confidence in the back end. It's been open source from day one, and it will remain open source moving forward, and we'll have some processes allowing the community to contribute and accepting community-based connectors and so on. So let's get started. So we have this new page that became available today on azure.com. If I hit this button, I'm going to go to this page. This page just allows me to get started very quickly, assuming I have an Azure account. A version that does not require an Azure account is coming quickly. And in this case, I have two function containers or function apps. The interesting thing here is that one of them runs on a traditional hosting plan. It runs on a reserved VM or reserved instance, which is just like what we know and love with Azure App Service, meaning if you already have stuff in Azure App Service, you're already paying for the compute. You can run your functions there, and nothing will change in how much you pay. If you want to try our new stuff, which we call dynamic hosting plans, those are pay-per execution, and you can create them here. So we'll start by looking at my dynamic hosting plan one. So this is, it says dynamic function, that's cool. And right now it's empty, and we'll walk through kind of creating the first canonical set of scenarios. This is where I talk about how the Wi-Fi sucks and so on. Great. So we have some kind of tutorial to get people started. The initial case is, hey, I have an event-driven thing, but the event is someone is calling my endpoint. It's a web API or a webhook. So I'll go ahead and click Create. And we try to create this tutorial. And it's all our fault. The design team had nothing to do with this UX. So we'll take all full responsibility. This code is in Node.js, and I'll show it in a moment. The interesting thing is our Integrate tab. We have three concepts in function. One is triggers. Those are the events that will launch your code. And then we have bindings. We have input bindings and output bindings. Input bindings are essentially data sources that are available to the function. And we'll show some of that. Input binding can also be a trigger. So for example, the best example of that would be a queue. The queue has messages that are being given into it, and those messages will then be available to the code as an input binding. Output binding is where I send data out. Let's go through this real quick. These are the function app settings. I can set my memory size, and I can access some of the functionality that lives in the underlying app service application that is under this. So let's skip the tour and start coding. So again, very simple thing. This is a Node.js endpoint. I can see my logs, and I can go ahead and just call it. So interestingly enough, I'll get this 400 error, and that's actually by design because I did not put a name on my query string. The query string, the request object is becoming a first-class object. The function framework is giving it to me as an object, so I have to go back and basically put a name here. Oh, the other guy is the other guy is already a parameter. And we get this. This, by the way, is an API key, which I can also roll, so I can use this as a web API. So if I go back to my function, my log will tell me that this thing ran, even if unsuccessfully a couple of times. And then I can go and say, let me make a real quick change here, hit save, refresh, and we'll see the change. So a very simple endpoint. If some of you know this competition that we don't talk about, 20 less clicks to get this going than those, River in the Safari people. But we don't, it's not like we're counting. So let's take another example. Let's say we want to run something every 5 seconds. And there's a reason. We'll pick C#. This would be a timer trigger in C#. Another language does not exist in South Lake Union. I'll stop with that, sorry. Yeah. So now we have this thing running, and it's going to basically just run every 5 seconds. So that's not really that interesting. But let's say that we really want to take this data, and maybe we're processing something in an input binding and send it to a storage queue. So I'll go to my Integrate tab. I'll add a new output, and we support many different things. And if we have time, we'll show DocDB, for example. And we'll select Azure Storage Queue. And we're going to select which storage queue in my subscription I want to use, and hit the Save button. At this point, my queue becomes a parameter that is known to my code. Because we're using the WebJobs SDK under the hood, all I have to do here is I can say outstring my queue, and then I can just do this. And that's it. That's going to be written to the queue. Oh, but obviously you noticed I screwed up and I didn't put the ampersand or the whatever this character is called. And the compiler caught it, and this thing didn't work. Your mic is on. Okay, so let me fix my my code here. We compile it. Now we're happy. And if we're going to go look at our trusty Azure Storage Explorer for Schnizzle, where is it? And we're already seeing this queue getting filled with my messages here. So every 5 seconds, this thing will go in. So again, very simple. It's running every 5 seconds. We're working on a better monitoring story, but this will come in and become part of the browser thing. but I can already see this in our live event stream, so I can see this thing going every 5 seconds. Those things are very inexpensive, so we don't even get, the system still thinks they're taking 0 milliseconds each, so we're not seeing the average time. So again, very simple way to get started. So that's all very nice, but it's not really useful. So let's look at a couple of functions that I've prepared in advance. And we'll go to my classic app. This runs on a dedicated classic app service, and we look at just one of them. And this is essentially a webhook. So we have, since webhooks are patterns, we have a generic webhook template. And what it does, it accepts a JSON body, right? So I can hit the run button here to test, and we're seeing this result. If I looked into my integrate tab here, our output is into Azure Table Storage. So I'll go back to the Storage Explorer, and we can see the test for hello build. So again, that's very nice. I have essentially a web API that allows me to go into a first-party table like Azure Tables, first-party service, but I really need to be able to call it from a web page. So I have this, again, very cheesy web page, not here. So very cheesy web page I wrote that calls this from kind of XML HTTP from the client. This is not going to work because I have to configure calls for it, right? So I need to go ahead and tell the web page that will call it that it's allowed for it to call this web service or webhook. So if I look at my function app settings, because I'm running on app service, I can go ahead and configure that this website is allowed to call this Azure function. So now I have this live. I have this web page that you've seen, and we can say, try again, I guess. It's always a good thing to do. And we've just written this to the Azure table. Okay, fine. And going back to my coding window, we should have seen some of these activities in my logging. So I think I have some more, but I think I'm running out of time, so back to you.
Yeah, all right.
Yeah, thank you.
Thanks, Steve. Nice job. All right. Yes, let's give them a round. Great demos. So the last few minutes that I wanted to spend up here was really sort of talking about, now that I've walked through those 4 big scenarios, and really 6 when you include the IaaS portions below, there really is this concept of putting it all together and sort of what this means as you're deploying applications. And some very simple examples to be able to put this all together, obviously taking components like we walked through already, being able to run a web app using parts of our Active Directory and SQL database and build a very, very simple solution as part of these components. Of course, scaling that out to a multi-region solution, and suddenly you're doing things like Traffic Manager and bringing in that app service using solutions like Redis Cache and SQL. These are things that we didn't talk too much about today, but they put together these components of multi-region web app deployment and make it very easy for you to get this massive scale solution using some of the very simple things that Nir showed you as part of that web app model. Now imagine if you wanted to also keep track of some sort of events that were coming out of these websites. As Nir showed you, those events, maybe they're dropping into something like Event Hub with functions sitting on top. And then it takes an action and takes that, whatever, maybe someone hits a button and that takes an event and then does some other action. These pieces coming together as part of this application model become very, very powerful to take this multi-region web application and being able to use the function story integrated with that web app story to create a single application model. Now imagine you wanted to put more of that web model together. You want to use mobile apps. You want to use the API service. Maybe you want to do notification hubs to get those events down to the phone. And maybe you're putting some things into table storage. Again, Nir showed you how to perhaps use functions on top of table storage to be able to take action and maybe send something off to your mobile device. So someone makes an order for flowers, maybe you want to send something off to the delivery guy that's got the phone. Function takes that action, pieces it together, perhaps sends that delivery address off to the phone, and that's the different part of the app that's built. So you can imagine, you can see how these things would come together. An actual real-life example, TalkTalk in the UK, who's got a video story. They've effectively taken Service Fabric, they've built solutions using the web app model and the API app, and they built Service Fabric as part of a queuing system that sits on top of storage. And so this actually does a queuing system, integrates with other services like Media Service to go do encoding of these applications, and Service Fabric handles all of that queuing state. And again, you can see how these components fit together as part of this all-up app. And the last one here that I'll show you is an e-commerce site. So a massive e-commerce site starting with web app, and this is pretty close to one that's actually running on Azure. Starting with web app, using Azure Event Hub for any sort of content or orders that may come through, using Service Fabric on top of table storage for any sort of systems of record, purchases that are happening, so that they're very, very fast on the stateful Service Fabric, and table storage ends up being that back-end replication just in case, and so for some more regional coverage. Maybe then you want to use functions on that and do an API app based on, again, delivery or based sending information out to an order site that then you can build additional apps on top of using API app. Maybe you're using Redis for the shopping cart as people are working on top of the app, the Azure web app, and maybe SQLDB with ML to be able to track trends or the way people use your site. All of this comes together to be able to build your entire solution, your entire site that you may want to deploy on top of Azure. And so you can see how these components, they help each other, they help support each other, and they serve different purposes and different goals. But when they all come together, you can suddenly build some pretty amazing things. So the last thing I'll end with you on is we talked all session about just Microsoft products. I want to leave and make sure you know that we don't just support Microsoft products. We do have some great platform offerings from partners as well, and I'm not going to spend any time on them right now, but these are great solutions if you're looking for Java solutions, if you're looking for other platform offerings. Cloud Foundry, OpenShift, Kubernetes, Elastic, and Apprender are all able to run and run great on top of Azure. And so that we are big supporters of these partner solutions too. But today's focus was, of course, on the Azure-specific platform offerings. So with that, I want to thank you guys. Again, the focus, choice, and agility. Go build those apps. Go enjoy those services. And again, please tell us how we did today. So thanks a lot. Enjoy the rest of the build.